We've been working on derivatives of trig functions, and we have looked at higher order derivatives. So now we want to put those two ideas together and look at the derivatives of higher order trig functions. All right, so let's start with just the first derivative. Notice that for x and cosine x, they're being multiplied, so I'm going to use the product rule. So I'm going to say first times derivative of second. All right, so what's the derivative of cosine? It's negative sine. So first times derivative of second plus second, which would be cosine, times derivative of the first, and derivative of x would just be 1. So first times derivative of second plus second times derivative of first is going to give me a negative x sine x plus cosine x. All right, so if we want the second derivative of that, remember, the second derivative is just the derivative of the derivative. So we're going to take the derivative of this guy right here. So again, in the beginning, we're going to have a product. So we're going to say first, negative x times the derivative of the second. The derivative of sine is cosine. So first times derivative of second plus, and then we're going to do second sine x times derivative of first. And the derivative of negative x would be negative 1. So first times derivative of second plus second times derivative of first. Okay, so we took care of this guy. Now we need to deal with the derivative of cosine. So what's the derivative of cosine? Well, it's a negative sine. So to simplify that a little bit, we could say I have negative x times cosine x, and I have a negative 1 sine x, and then another negative 1 sine x, so that would be a negative 2 sine x. All right, so that would be our second derivative. Now, if the second derivative was that challenging, then what do I do if they give me something like the 27th derivative? Well, I can only do that reasonably if I have something that has a pattern or a period. Let me show you what I'm talking about. So let's say that we start with y is equal to cosine x. All right, what's the first derivative of cosine? Well, it's negative sine. All right, so then if we found the second derivative, the derivative of sine is cosine, so the derivative of negative sine would be negative cosine. So if we found the third derivative, the derivative of cosine is negative sine, so a negative sine would be a positive sine. And the fourth derivative, the derivative of sine, is cosine. So then for the fifth derivative, when we take the derivative of cosine, we're right back where we started from, right? So the derivative of cosine would be negative sine, and then the derivative of negative sine again would be negative cosine, and the derivative of negative cosine would be positive sine. And we're just going to keep going with that same cycle of negative sine, negative cosine, sine, cosine, negative sine, negative cosine, sine, cosine, negative sine, negative cosine, sine, cosine. And I could count that out to the 27th. But then if they turned around and gave me the derivative of the 127th, I don't want to have to count that out. So here's what I can do. Because this follows a pattern of 4, I can say, all right, if I want the 27th derivative, if I take 27 and divide it by 4, that means that I would get 6 of these complete cycles, and then I would have a remainder of 3. So that means that I would want to go 1, 2, 3 into the next cycle. So if you'll notice, the remainder is the same as the number of derivative I'm taking. So the remainder is 3, so I would be looking for the third derivative. All right, let's look at another one of those. We used reasoning to get these down here, but let's go back and let's use this division idea. So if it were the 6th derivative, okay, if I came over here and I did 6 divided by 4, that would be 1 with a remainder of 2. So the 6th derivative should be the same thing as the second derivative, and yep, sure enough, it is. All right. What if we were looking at the 7th derivative? All right, if we take 7 and divide it by 4, we get 1 with a remainder of 3. So the 7th derivative should be the same thing as the third derivative, and it is. So you can see how we could use that to find a higher order derivative with something that had a period or a pattern where it repeated.